take them down and take them down and take them down. As you look, the whole room explodes. Take them down and take them down and take them. As you look, the whole room explodes.
Hi, I'm Javier Ramirez, and I want to tell you how we solve a problem we had for doing API analytics using two different NoSQL solutions, Redis and Bigquery, and a scripting solution. I'm one of the founders of teowaki. Well, that's my Twitter in case you want to complain or something. And one of the founders of teowaki, which is a two-people startup. And yeah, being a two-people startup sometimes can be difficult because you want to do things, but you know, when you are just a small company, you've seen this series, I guess. This is Walter White. He's in the fiction. He's like just a teacher in high school. And if you look at him, you couldn't expect that this guy is going to make like anything big, like making big money and having like a full-blown drug operation or something like that. Because, you know, you think like a drug dealer is like someone with, you know, with a lot of power, a lot of money, these things. But it turns out that in this fiction that I'm not recommending you to do, because they know how to do things, because they have the knowledge, they can actually, you know, make something kind of big. And if this story had any moral, it will be that if you know how, you can also do big things. Why am I telling you this? Because at teowaki, we got to a point in which we had a problem, and we knew we wanted to fix it with big data, but we were a two-people company. Big data sounds like something too big. Sounds like something for Google, something for, I don't know, people with a lot of engineers. And eventually, we managed to solve our problem, and I'm going to tell you how we did it, using a solution which is quite cheap and quite efficient for us. What's teowaki? Really fast, so you can know what I'm trying to tell you this. teowaki is a tool for team collaboration. It's like Yammer or like Google, Circle, Google+, or like a mailing list, but for developers and well done. So you basically can share links, best practices, profiles, code, I don't know, whatever you want to share with other developers. You have your stream, and you can have information coming from any external service. And our challenge is, even if the web looks that way you see, internally, we are an API. So internally, everything that's going on is just we have an API built with Ruby on Rails, and then we have a web on top with AngularJS. And we wanted to know how people were using the tool. First, we wanted to know if people were using the tool, and second, why. So if you are going to store all the information, all the navigation of the users, what's going on in all the application, quite soon you are going to get a lot of data. So yeah, we are not really smart, but we thought, yeah, it's going to be like quite fast. At the moment, we've been live only for 3 months, and we already have more than 2 million rows, which is like not much, but you know, it's like kind of growing. So at that rhythm, we will soon be in a place in which it would be uncomfortable using other things. But the thing is, 1 year ago, when we started to do this, we didn't really know what was big data. So we had this idea, okay, yeah, big data is when your data is too big. Okay, whatever. But also, big data can be when your data moves too fast, when it's too big, like order of magnitude bigger. For example, if I have like 500 users and 2 million rows, that's a different order of magnitude, that's big data. Or if the schema is like really weird. But to me, this definition is the one I like. If I have 300 million rows, and I can run a regular expression with a full scan, and in 5 seconds, I can get the 200 million rows of the result, to me, that's big data. To me, that's impressive. And that's exactly what we have now, what is available at the moment. So our requirements were we wanted to have something non-intrusive. So it should be fast, because if I'm going to be making the analytics of my API, I don't want to make the services slower for the users, only because I'm having metrics. Second, I had to keep the history, because today I'm going to present a solution, but probably in 1 or 2 years from now, there is a better solution, and I'm going to move. So I want to have all my history, and I can move it, because there are some hosted solutions for analytics that they give you only 3 months in the back, so I wanted to have my full history, just in case. I didn't want to be in a vendor lock-in. I wanted to do interactive queries, because maybe today I want to run a report, like a new one, that I just thought today, hey, how many people from Tel Aviv were, I don't know, trying out the site between this time and this other. And I don't want to have to write like a complex report in Java and execute on MapReduce to have this request. I want something like, I want it and I want it now. It has to be cheap, because we are 2 people, we are from Spain, we don't have any money, so it should be cheap. And if it's real time, that will be better. Not that we need it, but that will be better. So the first problem, for having something that is non-intrusive, Redis is amazing. You saw a few use cases. So all these people are using Redis. Twitter, Stack Overflow, Pinterest, Booking.com, WordCraft, Viewport, all of them sites that we really like and know. So and they are quite fast. They have a lot of traffic. Even things like Logstars or NTopNG, which are like system tools for log compilation or for network. Yeah, I know the faces. Every time I put here the Pinterest thing, people put the same thing. But yeah, the thing is, if it's fast for them, it will be fast for me. So what we are doing is every time we get a hit to the application, we are just storing it into Redis, and that's about it. So the users don't even realize that we are doing something there because it's really fast. In $5 per month server in DigitalOcean, we can have 125,000 inserts per second with Redis. That's $5 per month, so that's quite cheap. So it was not rolling. So the first thing was like quite easy. And you might say, hey, so if Redis is so fast, so interesting, so amazing, that's it. You have your solution. Use Redis for everything. No, you can use Redis for everything because it's going to keep everything in memory. And also because in Redis, you can't really do analytical functions, like aggregating data. If you want to do that, you really have to go through a really expensive way. You don't want to do that. So we couldn't use Redis for this. But so what we have is we are storing everything in Redis for a little while, and then we are putting it elsewhere. Where are we putting it? Second column. We want to have all the history. So where we want to store all this data that can grow potentially like too much? If you were asking me in the 80s, I will tell you I don't know. But today, just go to Amazon, go to the Google Cloud Storage, and that's it. You have a big file, you zip the file, you put it in a hosted server, and that's about it. So keeping the history is also quite easy. So far, nothing interesting. The most important part. Okay, I'm getting the data really fast. I'm storing the data on a server which is going to be like really, really cheap. And how you are going to run reports over potentially billions of rows interactively. So again, we didn't know anything about big data back then. And we thought, I don't know, we might use Hadoop because everybody's talking about Hadoop. And we give Hadoop a try. Problem with Hadoop is like MapReduce in a big level. And it's really interesting, it's really powerful. But it has a couple of problems. First, it's difficult to understand. You have to learn a lot of things. Then it's difficult to manage. If you want to install Hadoop, you need more than one server because only with one is not really the best use case. And you have to start managing the servers. You need Zookeeper to instrument everything. So it takes a while. It's like, and also it's not really suitable for doing like real-time interactive queries. If you have a lot of data, you run the report, and it might take minutes, it might take hours, it might take days, depending on your data, to get the result back. So it was like too much of a hassle. And we said, okay, maybe Cassandra, because Cassandra is like another usual suspect. By the time we tried it, it was not as good as it is today, as I could reckon from the talk of this morning. But still, Cassandra has a few problems. You can't run joins, for example, between different tables. If you want to do that, you have to use Hadoop on top. And also, administering Cassandra, putting it like properly to run your servers is not as easy in production. So again, it was a bit, too much for us and not as powerful as we wanted. Then we took a look at Hadoop plus Voldemort, which is something that LinkedIn was using. But it was Hadoop, so it was already a no. And Voldemort is like Redis, but for made by LinkedIn, open source also. It was a bit more complicated, so it was like, okay, we don't like this. And then we discovered Amazon Redshift, which is a hosted solution. And it was like, oh, this is good. If it's a hosted solution, I can just send my data. I can just pay for the data I'm using, and that should be easy to manage. And it's very easy to manage, but still, on Amazon Redshift, what you have is kind of a cluster of Hadoop on demand, and you have to start the cluster, feed the data, and stop the cluster, because Amazon always is going to charge you by the time you have the server running. So if I have the cluster running for 2 minutes, I'm paying for 2 minutes. If I have it for 24 hours, I'm paying for 24 hours. I don't want to be like all the time starting and stopping servers. And also, you have to tell Amazon how many servers you want. And that's not really convenient because I don't really know if I need 1, 2, 3, or 45. I wanted something like a bit easier. And then we discovered, well, those were the terms I told you. And when we discovered this, what is it? It's not buzzing. Sorry about that. OK, we discovered this, Google BigQuery. So Google BigQuery is a hosted solution in which you can basically send data, ask questions to your data, and it's going to work. So it's something designed for doing interactive queries over petabytes of data, which is exactly what we wanted. Well, actually, we wanted just terabytes, not petabytes, but anyway, in terms of which data you are sending. So even if I'm presenting my use case, which is for API analytics, what I want you to see is that if you have the need for consulting any data that you would like to do on your database, but your database is struggling with the load, you can just send it here. You can run joins between tables, inner joins, outer joins, anything you can do on SQL, almost anything. You can also do it here. So, and you can do even interesting things, like in GitHub, they are doing like subqueries for, okay, give me the trending repositories that were created yesterday and have at least 5 followers today. So they have this query. But trolling with this, we got to a point in which we said, you know what, I don't understand a thing. Because when I'm doing analytics, I don't want to have just queries. I want to have information. I want to have reports. Because having only numbers, having only rows is not really valuable information. I want to have like some graphics, being able to see trends, to compare with things. And we're thinking, OK, we have something quite interesting now, which is a BigQuery for running this kind of queries. But we will need something to do visualizations. And we started developing something in Ruby, which is our language of choice, like for doing graphics and so on. But then I thought, wait. If we want visualizations, maybe it will make sense just have a spreadsheet. Just have like an Excel will be perfect. If I can just send the data to Excel, in Excel I can have graphics. You know, I don't have to program the graphics myself because I know. Excel or in a spreadsheet is like, it sounds dirty. We are developers, come on. But it's really fast. You have numbers. You go there, select the range, create a graphic, and you know, you can do a lot of interesting graphics with Excel, especially if you have business people in the team. It should be quite easy. And we were thinking, wait, this is BigQuery, which is from Google, and Google has this Google Drive spreadsheets, so I am sure there is a simple way that directly you can integrate BigQuery with Google Drive spreadsheets. No. Yeah, I know. There is not like a direct way of doing that, but still you can do it. There is something quite interesting that I didn't know, which is called app scripts. It's a Google solution. Is like a subset of JavaScript, which is optimized for consuming any REST API, and especially the Google APIs. So if you want to do a mashup between Gmail, Google Drive, BigQuery, Google Analytics, any Google API, using a script is quite easy, and that's what we did. What we are doing now is we are reading every day from BigQuery, create a spreadsheet, and email it to a PDF. So every morning, I'm getting this email. Actually, now I'm getting a bit more. Every morning, I get this email, and it tells me, hey, you know, you have these new users, these users that died or removed. I don't care about them anymore because they don't love me. And you know, you have your data here. You have your spreadsheet. and that's quite convenient. So to do this, all you have to do is you go to AppScript, and this is the code, which is like, okay, give me the folder of my Google Drive, create a document, and with this spreadsheet, just add the new users, insert a new spreadsheet, add the deleted user, and send it by email. This is how it looks in my email. It's just basically, okay, so these are the receivers of the email. This is the spreadsheet. Just send it. It's quite easy. And this is the one for running the BigQuery query, which is like, this is the query that we are running every day. In BigQuery, everything is asynchronous. So if you are sending a query, you have to be like waiting until it's finished. So we send the query here, and then we could wait in until we get the result. When we get the result, we just populate the rows, and that's about it. So by doing that thing, you can have your, your data from BigQuery. You only have to think which queries you want to run. You have a really easy solution, which is just, keeping all the data on an Excel that you can pass to the business people or to yourself, and just run tiny graphics, and it should be quite easy. And it's like, okay, it might look like something that I want to use, but how much does it cost? Well, BigQuery is quite cheap, I will say. You pay every month $26 per terabyte. In our case, for the first million rows, we're paying like this amount of dollars per month, which is like nothing. And then per process terabyte, which is per each column, the number of columns that you are reading, per each terabyte, you are paying, oh, what happened? Oh, I ran out of battery. That's okay, don't worry. I was finished and I only have like 2 more slides. Per each terabyte, you are paying a ridiculous amount of money that you are reading. So basically, what we are paying for this solution at the moment is like $0.50 per month for 2 million rows. So until the moment that you get a big amount of data, it's quite cheap. Even when you have more data, it's still being like, compared to having your servers, having your people manage the servers, it's still quite cheap. It has a catch that I didn't tell you. It's in BigQuery, you can only add rows and read the rows, but you can't update. If you want to update rows, that's impossible. You need to create a new table with the new data. So in our case, which is for analytical things, that's quite, it's perfect, but we don't want to delete anything, we don't want to update anything. But if you need to update, it's not for you. But if you don't need to update, it's a solution that's quite cheap for us. It lets you have real time. It lets you have 100,000 inserts per second on real time. And yeah, I'm sorry you couldn't see the last slide because it was quite funny. But anyway, that's what I have. That's what I wanted to tell you. And if you have any questions, so I will be glad to answer them. Thank you.
Any questions? There we go. This table very popular today.
I saw that your use cases look very similar to what you can get with Google Analytics. So what's the difference?
Yes, the difference is I have an API. Google Analytics, you have a JavaScript that you put on your website, and you see the traffic. But when you have the API, people are going to call you from a phone, from a command line interface. You don't control the endpoint. So if you want to control the traffic from the API, you can't use Google Analytics for that. You can use Google Analytics only on a website, but not on the API, which is where developers are going to connect directly.
Oh, okay.
So that's it. But yeah, other than that, Google Analytics is built on top of this thing. I mean, they have actually, if you are like a premium customer, they give you the option to export every month your data from Analytics to your own instance of BigQuery. So you can ask for other reports than the ones that they have by default. But yeah, it will be perfect with Analytics, but we couldn't use it. That's it?
No, one more.
I saw that you're connecting to BigQuery with Excel. Why don't you use Simba driver that exposes ODBC connection? BigQuery.
Sorry, I'm connecting in BigQuery with?
Are you familiar with Simba driver? Simba driver.
Simba? No, I'm not using Simba.
It gives you ODBC connection to Google BigQuery.
Yeah, I mean, you can go to BigQuery from many things. I think, for example, we have another project, and you are connecting from Logstash also to a BigQuery. But the thing is, what we are using at the moment, since our API is running on Ruby on Rails, we have a Ruby on Rails library, and it's the one we are using for that. But yeah, you have connectors to BigQuery from many different languages. So probably with Simba, you can also, send it. But at the moment, we are using Ruby, so that's the client we are using.
Okay.
But yeah, there are connectors for many things to BigQuery right now.
Okay.
Thank you. Okay, that's it. I'm going to be here around, so if anyone, and later in the party, so just feel free to ask me. Thank you.
Yay.